fell in love, so deep in love. Let's go. You are my paradise, I can't deny. You make me high. You are my paradise, I can't deny. You make me high. There won't be no goodbye. It's no surprise. I'm hypnotized. Take me away. Love is forever with you. I mean no shame. Believe. When I look into her eyes, I see paradise. When I look into her eyes, I see paradise. When I look into her eyes, I see paradise. When I look into her eyes, I see paradise. When I look into her eyes, I see paradise. When I look into her eyes, I see paradise. When I look into her eyes, I see paradise. When I look into her eyes, I see paradise. Together we go to a city where there's no pain. Believe. Take me away. Love is forever with you. I mean no shame. Believe.
That's what I'm talking about.
Wait! Okay, now, from the beginning.
Hit it, boys.
joint on a corner where the big boys play, where the whiskey's running like the rivers, but they all never come for the booze and bass. I'm the one, I'm the lady that'll rock this place. That'll rock this place. That'll rock this place. Rock this place. Rock this place. Rock this place.
Okay, now, from the beginning. There's a joint on the corner where the big boys play, where the whiskey's running like the rivers, but they all never come for the booze and bass. I'm the one, I'm the lady that'll rock this place. That'll rock this place.
Are we good to start? Oh, there are more people coming. You got it? Is it working? Okay. Okay, I'm gonna make a start. Good evening, everyone, and welcome to the IET Wednesday evening lecture. Just a bit of housekeeping first. There's not meant to be any fire alarm today, but if you do hear the fire alarm, our evacuation point is at the Waterloo Bridge. Yeah, try not to jump into the water. Okay, so we are thrilled to have you join us here today at the Savoy Place tonight. We will delve into a topic that's both timely and critical. It's on the system integrity, physical and cybersecurity integration in railway. As technology continues to shape modern railway systems, the distinction between physical and cybersecurity becomes increasingly blurred. The need to integrate these domains has never been more important. Through tonight's presentation, we will explore the challenges, best practices, and innovative strategies that are shaping the future of railway system integrity. We are fortunate to have two distinguished speakers with us this evening. This is Tawase Tortif Ato, a technical director and a chartered civil engineer with a vast experience in complex infrastructure projects. Ter's leadership on projects like the High Speed 2 Euston enabling work highlights his expertise in merging physical and operational safety measures into ambitious engineering endeavors. And here we have Duncan Hui, a consultant specializing in railway system integrations, system engineering, and cybersecurity. With experience spanning projects such as East-West Rail cybersecurity assurance, Duncan brings valuable insights into safeguarding railway infrastructure against digital vulnerabilities. Together, they'll provide a comprehensive overview of how integrated security approaches can enhance efficiency, safety, and resilience in modern railway systems. Now, without further ado, please join me in welcoming our speakers, Ter and Duncan.
Welcome everyone to this evening, to our lecture today. Let's go with the agenda. So we kick off with again a brief introduction to ourselves, TOEFL lecture just given, and then we move on to look at what the contemporary security practices are in the modern railway industry. And what an integrated security risk assessment will look like. So this is just a process that looks roughly based on the TS 50701 standard. And finally, what are the best practices and benefits to this process? And we'll close the evening off with some Q&A sessions.
So as Nach already introduced us, so we'll probably keep that nice and short. My day job, I'm a civil engineer. As you rise up the ranks, to find that you stop doing less of what you use your day job and start doing more and more of management and stuff. So that's how I got into physical security, cyber security, not so much, but having to bring it all together to make it work as an effective system and resilient system on the railway. I'm currently technical director at Atkins. I sit in the rail systems and infrastructure practice with Duncan, and work on projects that Nach already described. Sometimes really small projects cost the £2,000 to multi-million pound endeavors as well, supporting others to try and bring it all together. So this evening we'll be talking about physical and cyber security integration. We're not going into very great detail, but we just want to explore ideas of how best we can make sure that these two critical disciplines, I would call them for now, can ensure they are talking to each other as we work on railway systems. Thank you.
Thank you. As Nach mentioned, I sit in the rail system and infrastructure practice at Atkins, and I've been a consultant for 4 years now. My experience is mostly on systems engineering, but I've worked on the highlight of which is the East West Rail job, which I looked at the cybersecurity assurance and how easily the similar systems, the operational telecoms, station telecoms, and EMP systems can be potentially compromised. So a lot of that will be based on that experience.
So we want to kick off with the need for security integration. So we've started off with a little diagram or a mini org chart, if you like. For those of us that work on projects would recognize project org charts. So we've picked out this one to just demonstrate what we want to talk about. As you can see on this org chart, the cyber security appears to be sitting under a different org structure, if you like, compared to physical, which tends to sit under engineering in most instances. Cyber then sits under systems, but the two have to talk to each other. So that's what we want to explore tonight as the need. So quick definitions, just before we move ahead. Physical security, it's the one we all recognize as the one we can see. It's the fences, the boundary fences, the doors, the physical barriers that prevent unauthorized access. But also embedded in that, what we don't see so much is the resilience in those systems, and how those systems talk to cyber systems that also contribute to making them function effectively, like our HVMs and the rest of it. And then for cyber is what we talk about more often these days, and probably in the last decade, the electronics, the integrity of them, our communications these days is all electronic. We all work online every now and then, making sure that all of that is safe. But on the railway is even more important, because all of these systems, like signaling, access controls, the CCTV, CIS, and all of that. That's what we'll be talking about from a cyber perspective. And integrating this, we want to look at the benefits of integrating this, make a case really for it. There's a few, at the end of we feel that once all of this is done in the way we are suggesting, it should ultimately lead to reduced costs. And we can achieve that by sharing mitigation and controls across both disciplines. Because when you look at how both disciplines start off their projects, they always start with risk analysis. And inevitably, there will be same risk, there will be shared risk on both sides. So we're saying, why do it separately? We're not arguing for an individual doing both, but we just want both individuals talking to each other to make sure that we're getting efficiencies and we're covering off all the open threats, which comes out to when we talk about sharing threat intelligence. There's a whole lot that will come to us as we go through the lecture And the intelligence very often is common. The malicious actors that we try to prevent from harming us, they're always looking at both aspects. They look at physical, they look at cyber, and sometimes they look at both. So we need to be ahead of them by also considering both. Then looking at the response to incidents, again, you might argue that they are different for both, but what if you get a combined attack? And what if you get an attack on an access control systems, an attack to a gate, for instance, which is electronically controlled, and that control ultimately leads back to some server room somewhere. So you find that you can't really talk about them in isolation anymore. And then all of these, bringing this together, gives us better diagnostics of the problem. It helps us to build a more resilient system that can then withstand any shocks, if you like, and then helps you to respond better where there is a combined attack or an attack that probably not planned to be combined, but has the inevitable knock-on effects because of the way our modern-day systems and infrastructure work.
Okay, thank you. So what are the recent industry developments that reflect this? So we start in the UK. So a lot of you might be familiar with CPNI. That's the Center for Protection for, I can't read that, Center for Protection of National Infrastructure. So that mainly focuses on physical security, and they've got a series of policies and standards and guidance on how to assure the physical security of a nationally critical infrastructure. But that, as recent as 2023, that's actually been replaced by a government organization called NPSA, National Protective Security Authority. And they've got a series of guidance and framework that they released called CAPS, or CAPSS. And that stands for the Cyber Security Assurance for Physical Security Systems. So they brought in an element of cybersecurity into what a physical security systems and to ensure this overall system integrity as well. At the same time, a lot of you will know NCSC, so there's a standalone cybersecurity agency that sits under GCHQ. And obviously, the cyber has been a hot topic for the last decade or so, but it's also interesting to see that the cybersecurity is being considered from the physical security point of view. And looking wider in the mainland Europe, in one of the examples that we found is that in the European Union there's a funded project called Safety for Rails that ran between 2020 to 2022. They was mostly looking at the safety, integrity for mainline and metro systems, but they've got a few projects that look at integrating cybersecurity and physical security and how that can be beneficial for railway operators. And they classify the attacks into a physical-only attack, a cyber-only attack, and a combined cyber-physical attacks. So regarding all these, each of these types of attacks, there are different measures and different mitigations that you can implement. And across the other side of the pond, in the US, the US Cyber and Infrastructure Security Agency have published a paper called Cybersecurity and Physical Security Convergence, and highlighting what a organizational function would look like if you combine the cyber and physical function together. So on the top there, if it works, it's very small, but on top there, in typical organization, you often find the CISO looking at the cybersecurity side only, and you find the chief security officer looking at the physical side only, like workplace violence, the physical access to the premises, etc. But they often work separately, and obviously there are a number of disadvantages, like they operate independently, the threat intelligence are not shared. Even worse, if they've got mitigations or assumptions that rely on the other discipline that they're not communicated through, or even they have conflict against each other. So if the controls are working against each other, that might not be discovered until very, very later, until there's an incident that actually happens. So by integrating these two functions can potentially address these issues, even just by from a management point of view.
So we're proposing some form of integration. No doubt it comes with its challenges. Probably it's easier said than done. But we've tried to touch on a couple of the challenges, not very many of them, starting with the organizational silos. this organizational silos it does happen in many organizations, but the surprising bit, you would say, is how deep it happens with projects. So you have a small project, maybe not so, maybe a project team of 50 on the maybe medium to larger size projects. Even with just 50 people, it would be interesting to see that there's 50, maybe there's 5 groups, and the 10 people literally, not necessarily not talking to each other, but just assuming that, oh, they already know who I know, or even though they don't know it. And so making sure that there is a strategy to integrate these two critical aspects of security from day one at organizational level will help to mitigate that. And the challenges they sometimes face with the integration, it's different budgets, different reporting teams, and all of that nice things that we need to do at our company levels. But generally, we feel good cultural shift is the main thing, because irrespective of your reporting lines and all of that, if we all have that mindset that all the individuals in a project team should have access to more or less the same information, especially at physical and cybersecurity level, that would help to overcome that challenge. So we took this quote from Tim Cooper, one of our colleagues. He did in a recent internal publication, saying that essentially you need to plan those resources from day dot, and make sure that you've considered all the activities. That then sets the pace and gets everybody going. We're focusing a lot on project level because we know that this is scalable to organizations. So if you get it right in the organization, it's going to work well for the project and vice versa. So the other challenge we did think of is the disparities in technologies for physical security and cyber. Cyber already lends itself to technology and is racing ahead. There's changes, not much for various reasons. There is an onerous testing regime to bring a physical security product to market. And also the testing cycles is such that it takes them a lot longer to bring a new product to market. So they're always playing catch up on technology. But if we get to the point where both are working in synergies, like we looked at earlier on, I think we're going to start to cut down the time scales, how quickly physical security products can come to market. Then the other challenge is data usage. We collect loads and loads of data. Even in our everyday personal lives, we have so much data. Averagely, including spam, you probably might get 100 emails a day. You only get to read 1 or 2 effectively. The rest of them you scan over. So, but there is a lot of good data still that just sits there that we don't do much with. So it's thinking about how best we can manage this data, what we can pull out of it, and how we can develop it further. We're probably not going to do a lot with it, but if we take any incremental steps, that would help. So again, we did pick on a quote by the Chief Constable of the British Transport Police. She was on about how much data they've got, how much CCTV data they've got, how much they see every day on the stations, all the recordings. They've got so much. They've not touched, a finger in the air, you probably say they've not looked at 10% of the data they collect, and it's usable data.
Thank you. So we've talked about a lot on the challenges and obviously the benefits on how integrating them by benefit would be a good thing. But in terms of what exactly are we integrating? And when we look at security, the first thing that comes to mind is risk assessments. But before going through the process, let's look at what elements in the physical and cybersecurity side that we can maybe depend on each other or they have something in common. So on the physical side, there are some elements that are unique to it, like the physical security standards or station protection standards. And on the cyber side, you will have the networking diagrams, you will have the security architecture diagram, or cyber security standards that are applicable to digital systems only, like 62443 series, for example. But when you look at a generic risk assessment, they are very similar between a cyber TRA and a physical TVRA. So first of it, before you start risk assessment, you look at what do we need to protect actually. So imagine combining this into a single list with both digital systems and the station itself or any physical item. And who are the attackers? So it could be a hacker, but it could be a hacker actually help initiate a physical attack if they try to disable a physical access control systems. And what the vulnerabilities are. Again, using an example of an access control, if you got a 6-inch steel door with a keypad entry access, is it really working if you got a keypad on the outside that's put on by 4 M4 screws with unencrypted data transmission? Probably not, especially if there's no CCTV on the premises. So these are the dependencies that you might want to highlight if you're integrating both disciplines. And you can also combine all the physical and cyber risks are together, and also what are mitigations that you can put in place to design that resilience into the systems. And what the requirements are, because if you separate the physical and cyber security, you have the cyber security system requirements, and you have the operational requirements for the physical side of things. So are they really conflicting against each other, or are they missing any gaps as well? So again, these are the dependencies, or they actually the requirements lead the assumptions of another discipline to actually work. Again, these may not be highlighted if you separate them. And finally, what the response is like. Do you need an on-site team to actually mitigate an attack? Depends on what type of attack that is. And in terms of security operating center, are they capable of dealing with a terrorist incident, for example? And what sort of terrorist incident you need to mobilize all the resources that you need to mitigate a possible foreseeable attack? So we identify all the elements. Time to look at the processes now. So this is an overview of what we propose. Again, this is very high level. This is not a step-by-step guide. It's a piece of material that gets your forerunning of what that will look like. So in this very high level 4-stage process, if we start off with identifying what assets are we protecting, gathering data, knowing what we're dealing with, and then move on to analyzing the risks themselves. This can be a qualitative risk assessment, quantitative risk assessment, putting a risk scores against it, and what the requirements are. Again, combining integrated security requirements rather than separating them. And what are the possible mitigations? So working through on the ALAP processes, can we design resilience? Can we make changes to the systems or assets? Are you complying to the relevant standards? Choosing what standards are you complying? And if you can't make changes to any physical hardware, can you train the staff to allow them to mitigate or respond to attack, and sharing information and also lessons learned across projects as well? And finally, do you need a response plan to mitigate or to be more resilient against a foreseeable attack? And how do you recover from a disaster? So we'll look at these in more detail right now. Starting off with the first step on the asset impact assessment. I'm not going to go through all these steps, but essentially we start any risk assessment, we need to define the scope. So getting all the information on what we're dealing with. So when we combine both physical and cyber, so you might look at the civil structures calculation or the buildings plans, and also networking diagrams where the servers are located. If you've got safety critical servers, there's actually a thin wall away from a locker, say, that might be discovered at this stage now. And this is where you establish that as security dependencies. So what I just said, what I just said, the access of a certain secure and critical server that might be depending on a access control system that, as far as cybersecurity previously wasn't aware of, or it might be just operational procedure on the local site. So this way, if both disciplines working together, this can be highlighted, and this can be discovered and shared within the integrated security team. Then you conduct the vulnerability assessment. You need the experts from both sides to see what the possible vulnerabilities are and what are the possible attack scenarios. So these are just very foreseeable, reasonable attacks. At this stage, and also how these assets can be accessed by the staff or members of the public. And then you can move on to identifying what the possible threat actors are. They could be members of the public, or it could be just a maintainer plugging USB sticks, or it could be a disgruntled employee. So most of the attacks they can possibly initiate. Again, this is a very rough procedure that loosely based on 50701. You'll find we don't have something like SLT or SLC or SLA in there because those are iterative risk, security levels. But the idea is to highlight what are the possible steps that both physical and cyber security can work together and improve the overall system resilience.
It's essentially thinking about the how both the common risk between both assets, if you like, from physical and cyber perspective, or maybe the common threats. For instance, from the physical point of view, your access control, maybe you've got an entry gate, SS3 rated or SR4 rated, whatever the rating is, but that rating, Duncan touched on previously, you've got an access that can be unscrewed or is unencrypted and all of that. So the designer of that door is depending on the integrity of the cyber security of the lock on his door. So when they are not talking to each other, then the aim that gets defeated really. The door, it's no different from any other door that you can kick out, if the cyber and the physical are not talking to each other in that example.
Yeah, so now there's an example. So reading through these lines from the right-hand side, let's say the premises is to introduce this new signaling control system and a new in a real operations center in the ROC. So we start with gathering what the information that we have now. So that could be the existing system, the existing design of the interlocking, what the control systems are, what the interfacing systems. Do they connect to the neighboring signal control center? Do they report it to, or is it a data sniffing service that's branched out to the security operations center? What sort of line sign devices or line sign control units does it connect to? So getting as much information as possibly could, and also the physical design of the ROC as well. What sort of procedure do we need to access those systems? How does the ROC actually protect the hardware in question? So these are the possible questions that you might be asking yourselves or the stakeholders, mainly around the protection, and what are the possible attack scenarios. So looking at cyber only, physical only, or combined attack scenarios. Again, these are reasonably foreseeable attack scenarios. It's impossible to think of everything, but it's nice to get that first draft on paper to think about whether the existing design is adequate. And also what the threat actors that will initiate the design. So the last two steps, they work together to form the overall threat landscape scenario picture. Now the next step when it comes to analyze the risk. So we identify the threat actors. We know who are the biggest threat that who will possibly initiate an attack. We also know what the sources of all the risks are. And then we can define how the security breach can be initiated with these threat actors. And then we can move on to actually proposing the list of risks. So this can be both physical risks, cyber risks, combined risks, or certain cyber risks that depend on physical vulnerabilities, vice versa. And once we know what these risks, using the expertise or review with the other stakeholders, we know what these consequences are. So we have the risk, the consequences, what will happen. So you might propose a series of primary consequences or secondary consequences, depending on how far you want to go within your project. And then after that, you might propose a risk score, do a quantitative analysis, and also, as usual, do a workshop with the stakeholders, get these agreed. If they're not, it's an iterative process to build up that level of risk and knowing what risk you're dealing with and what are the possible consequences. So when these get agreed, you know what are the possible threats, what are the risks, what are the consequences, And you can start drafting the requirements, security requirements to constrain the design, or constrain how the design is operated, to feed that into the system design, the building design, or the operational requirements.
Yeah, again, it's just going through that list. When you get to that point, compare security requirements, that constant thought of physical and cyber, and going through the process each time, iterative as many times as you need to go through, just making sure that you're thinking about it from both angles and speaking to the right people, and nobody gets left out of the loop. Right people also include, most importantly, the operational people, because there's a project we worked on some years ago where we'd done everything, we've spoken to everyone we thought we needed to know, including the BTP and everyone. And then when we got to implement, we found out from the station manager that actually this area that we thought is covered is actually a dead zone, because most nights they're going to have barriers all around it. So that place is actually hidden most times of the year. You can't actually picture anything using a remote camera unless someone physically goes there. So it means if you spoke to him earlier, you probably find a way around it. But in that instant, we had to put in an operational responsibility on them to make sure someone went around there to inspect every hour. But you still got that risk in between the hour. What happens the period where he hasn't gone there? So it's really important that everybody that needs to be spoken to is involved in this risk analysis process.
And now if we consider a second example against this process, let's say we are building a new station, then we can identify the possible threat actors that will be using the station. They could be classified as malicious, non-malicious, external and internal, from the cyber point of view. Roughly the same can be applied to physical security as well. So it could be a disgruntled employee or station management staff that's inadvertently putting in their own USB sticks that's been infected. Or it could be unruly passengers, a foreign state or terrorist attack, or a hacker if they're external malicious external actors. So the possible vulnerabilities, they could be, we can look at it from the cyber only, physical only, or combined vulnerabilities as well. So like an example of a cyber only vulnerability could be an open network switch port, with a switch being located in a public accessible area, say on the platform or on the wall somewhere. Or it could be a physical only, that the station concourse is open to a vehicle attack. So any lorries that lost control, they can just drive straight into the station concourse and cause massive damage and casualties. Or it could be a combined attack. So let's say the telecommunication system can be disabled really easily, or to facilitate another types of attack. So to slow down their response time. So I just said these are possible risks, and the consequences so builds into that as well. It could be a compromise from something as compromising personal data, or even just allowing unauthorized access to a station and causing casualties and damage. And finally, conducting workshops and get these requirements defined. So now we have the requirements. We know how to constrain the design, and now we know how to mitigate those risks that we mentioned earlier. Again, the standards will fit into this process to have the complete requirement set. We're highlighting these dependencies. This sort of Venn diagram was about earlier as well. It's also nice to bring in the lessons learned at this point. So some other projects, they might have already encountered this, or an ongoing projects that might be having the same problem. It's nice to share that knowledge to build up that even more complete pictures and what the more complete mitigations could be. But just before you move on to the design. And now at this point, you should have everything that you need. You've got standards, you've got the requirements, you've got the lessons learned from the other parts, and you can start to see if it's possible to design that system security resilience into your project. If not, you can move on to if not, you can move on to implement that against for the organizational management method. But it's also important when you implement those security controls, you evaluate them immediately, so that you can see if they are adequate or not. So you might have to go through that risk assessment process again to evaluate that mitigation. So different types of possible organizational risk mitigation. It could be internal training, or it can be just threat monitoring or through data sniffers. What the possible are there any abnormal activities that might indicate an incoming threat, or is someone just probing your systems, or just a periodic checks on the system healthy, on the system health, and derive from there. But it's also, again, that document the lessons learned, document what information that you have obtained, and to share that within the organization and any trusted external organizations as well.
So on the mitigation piece is really, again, important for both parties to talk to each other, or everyone really on the project. An example of this would be where, say, you've got a critical, let's say server. Your server needs to be a certain proximity to your the infrastructure you want to protect. You probably can't take a mouse away. If you're in that, you've got that kind of scenario, then what would you do to make sure some insider, so to speak, or even clever person discovers that is where the backbone of your system is? How do you protect that? Do you use another server to protect it? Probably you can do, but there's limitations to that. So in that instance, an option available to you will be making the building resilient. For instance, in where we process mails, you might want to protect that area. So the resilience in that area, physical point of view, the buildings, the walls, everything around that enclosure is going to be more resilient. So if a blast goes off in one part of the building, even close enough to the room you're trying to protect, nothing goes wrong. Your server is still intact. Your server has got battery backup. It's got emergency supplies and everything. So that kind of highlights how they rely on each other, and they need to be speaking to each other to make sure you don't assume that it's going to be protected when it's not.
Using a different example, again, if we are designing a new metro line in a major city, once we have defined the system requirements, we can implement these requirements into the design, such as blast-proof control room or surface room to protect the interlocking or control systems and communication systems. Do we need redundancy for the access control in the stations and also in the tunnels? And think about the signaling control unit as well. Are they in the secure area, or are they on a platform that can be opened with any key, or just can be pry open easily? This is something that inherently is difficult for railway, because in the industrial control system, let's say for a factory, a lot of the field level sensors or field level surfaces, they are inside secure area. But in the railway, they inherently dotted around a large geographical area. So your one part of the system is always exposed to the outside world. It's impossible or not feasible to protect everything that you have designed for. So there's always the challenges in the railway world compared to, say, in a factory. So once we highlighted the cyber physical interdependencies, and then we can implement these ongoing mitigations at this point. So now the final step. So when we're about to enter the system into operation. So now we've got the mitigations now. So we can again look at what are the possible incident responses against the attack scenarios that we have earlier. We need to work out what the reasonable and foreseeable attacks are at this point. It's not possible to see everything. We can also baseline the existing responses against these scenarios to work out the response and prioritize these against the response times. With the highest response time, you start to think about if it's a credible attack, but we have got this much response time, is that acceptable or not? If it's not, you might think about how you can change the design to improve the resilience, or to train the staff so it can be or acquire more resources from elsewhere to mitigate that possible attack. And all this information, once you go for a bit of brainstorming, you may put that in a document, in an incident response plan, so you got standard operational procedures to mitigate and to follow once you've got a possible attack scenarios. It is not possible to predict every possible scenario, but if the staff are well trained, if the staff knows the nature and the principles of the responses, they can use that guidance and procedures when an attack happened. And then you can move on to damage control and recover the system back to a normal activity or just degraded mode to keep the railway running safely and as efficiently as it possibly could at that stage. So once you recover from all that, document it, update what lessons have you learned, and continue to build up that industry-wide security resilience. Finally, more example, believe it or not. So again, using an example of building a new metro line, say the attack scenarios is to bridge the signaling systems. So that's credible. It's been done before, but has the metro operator got enough resources, or has the design secured the existing design or systems in place properly to mitigate that sort of attack? If not, do you need to consult a security company to help dealing with response then, or do you need to train the staff if there's cyber security, or have you received intelligence if there's a physical attack that's imminent on the systems? And how you can use both resources to counter these individual threats as well. And once you've drafted this integrated response plan, this sort of feeds into an operational procedure of what to do in an emergency.
Yeah, so on the response piece again is both disciplines talking to each other from the assumptions we make when we plan our responses. What are we relying on the other party to provide, and have we communicated that clearly, and have they confirmed that they are going to be providing that? You know, for sometimes it gets a little bit more complex. We've worked on a project in the past where we had some clever access control systems that would limit opening to 2 doors at any one time, but the fire engineer in his strategy required all doors to open once the alarm goes off. You know, so you're in one corner, you're thinking, I only need to keep 2 doors open, and with these 2 doors, I've got my cameras, I've got my controls, I know what's going on, it's not going to break. But the other party wants everything, all doors absolutely unlocked as soon as there's a fire alarm. You know, so what do you then do if you're not aware that that's the assumption? Then you wouldn't think about that, and your system already has an inherent vulnerability from day one. You know. So talking about best practices for integration, there's a whole lot we can think about in this space, but we thought to bring it into four areas just to align with the strategy we've used so far, talking about 4 key areas. So if we start with looking at the unified security governance, you'd argue that you really can't unify it, but I don't know how many of us are designers in the room, but when you think about it from a designer's risk assessment point of view, and when you work on a project, it's a multidisciplinary project, you've got the electrical engineer, the civil engineer, and everything. We've got separate risk, but we can put it on a single register. We can all think about it separately, but when you put it on a single register, what's going to happen is the other parties will have no choice but to read it. But when you all operate on separate registers and you circulate your registers, they're not going to read it. They're just going to file it somewhere and bring it out only the day it's needed. So when we talk to each other, we can develop that unified security governance. So we need this to happen at corporate level or at management level. But when it comes down to project level, I think in our small projects, we can make that conversation happen and try and establish it from day one. And then obviously we need the experts in the room. This is not one where the project manager sits down with the engineering manager and make decisions. We absolutely want the experts involved, the physical experts, the cyber experts, talking to each other, sharing information on all aspects. No doubt, you need the controlling mind, so to speak. You need that mind that is across the piece, but the input of the specialist is critical. Security technologies we touched on earlier, there's always that lag between physical and cyber. You could argue it's closing, maybe not, but we still need to find solutions around that. The electronic solutions for physical processes or physical protection. We got clever access control systems these days, even in our homes, where you approach the door and it opens. So what happens in between is probably one we probably don't know very much about. I mean, there's all sorts of things we hear about, the simple doorbells we've got at home these days. You can control it from your phone and anything. So if someone is taking control of your phone, remotely, and you probably don't know that they've hacked into your phone, could they let someone into your home whilst you're at their work? So what are the measures that you could put in place from a physical perspective to mitigate that? And thinking about aggregated data is what I probably just touched on. Also, once we looked at the integrated technologies aspect, we also look at training. Training never ends, and the important piece I wanted to highlight on this training is the fact that it needs to be everyone. Again, I bring it down to a simple construction project. Over the years, from 2007 to 15, where we CDM go embedded in our vocabulary and everything we do in our practices, especially on the railway. We're all strong on health and safety. Whether you're an admin person, you're office cleaner, whatever you do, you start with health and safety. It's paramount for everyone. So I think that is where we also need to get to with security. We need the entire organization, everyone, absolutely thinking about it and making input into our everyday decision making, especially at our project level. So when you sit down at the beginning of project meetings, you have a security moment. You bring up, you have to ask people to think about what could go wrong from a security angle. So it's just getting everyone into that mindset and the organization ensuring that we are all trained continuously. So as blast engineers get their training, the cyber security people get their training and all of that, we need every other person not involved in these two disciplines to also get some level of training so that they have some awareness of what could go wrong around them. Then the incident response we've touched on a few times this evening, it needs to be coordinated. We need to know what we're relying on from a physical and cyber aspects. When the door flings open, where do we need people to go to? Is the area safe? Could something go wrong there? What's the cameras in the area where we're evacuating people to? Will they be affected in the original blast that caused the evac in the first place? The other kind of thoughts that we need to think about. And then using the resources. When we have this, not necessarily uniform training, but if we have a baseline training that cuts across the piece, it then makes it easier for us to share resources in times of emergencies. Because what could then happen is you find something goes wrong and it impacts the physical specialist more than the cyber sometimes, or vice versa. But if we have a baseline knowledge that is shared across the piece, then it helps with our resilience and in responding to incidences. And then regular drills. Pre-lockdown, we did a lot of fire drills, probably not so much these days. But the thing about drills with this security is understanding what the advice is from the security services at the time. Because once upon a time, we were asked to evacuate to a certain area. Each building needed to have an evacuation point. But there was a period when we got another advice that no, do not congregate. If you evacuate, disperse. So we need to be on top of that as well. So that it's important that we're speaking to each other, cyber, physical, operationally, so that we understand the advice of the day and manage our evacuations accordingly.
And I think the theme of benefits are basically embedded into the whole presentation. But just to recap, so we'll start from the start of the project life cycle. We look at what assets do we need to protect. The minimizing the risk of having gaps is a really big one. So those in terms of both identification of what we are actually protecting, what the assumptions are, what the dependencies, and what the mitigations are, or even the operational procedures. If they're conflicting or they are making an assumption that the other discipline will do it, this is where that will surface. And also improving the efficiency in identifying the scope of what you're trying to protect. When you come to doing the risk assessments, there's a single source of truth of what the security risks are, and these risks they might not they might not be contradicting to each other, or and you can establish the interdependencies at this stage. The risk assessment, the risk scores, we get a more accurate score because you have both experts working together. So if you've got a risk that the cyber security expert has said it's not important, but it might be really, really critical or really high risk from the physical point of view, you will give a more informed score at that point, and to take that particular risk to the next stage in the project. And you can also consider any combined cyber-physical attacks. So in this very niche or these serious scenarios, we get documented and properly look at if you integrate both physical and cyber. There will be a more robust traceability of what the security requirements are against the design, because you have a single source of requirements. Again, improve efficiency of design iterations, because it's just design team interfacing with the security team rather than just physical and cyber. If there's a conflict in between, you need to resolve that conflict somehow. And as a result, you build better resilience for the railway systems. And finally, when you're operating the asset, there's an improved response time, but there's potential of improved response time for this sort of attacks, because you have shared resources, both the people, the staff, and also the tools that you need to counter attacks. You might also have the response plan with a set of pre-planned operational procedures to mitigate that attack, to minimize that response time as well. So finally, we went through a lot of examples. So we went from a very abstract idea of what an integration security would look like to what elements that are dependencies, to what for what different stages in the security systems will look like. So what if we start from the beginning to the end with one system only, and cyber system, digital system that inherently span across a large geographical area possibly, and physical security is often about protecting access, protecting buildings, infrastructure, and human lives. So access control is the first thing that comes to mind. It probably will be going forward. So let's say if we are designing an access control for a major transportation hub using these steps. So if you're designing a big station, you gather what you need, and in the first step, you gather all the information that what you have. So looking at for example, looking at what the back office area houses. There could be a station management systems, the SCADA, what the staff accommodations are like, what the control room, where the control rooms are located, what sort of data are they exchanging, what the system narrative designs to allow that SCADA system to work, who are the threat actors are. There could be the general member of public or any hackers or foreign state. So getting as much information as you can in the first step. They do a risk analysis. What the possible risks are. So how can the access control system be attacked? Can like Ter said, what if someone triggered the fire alarms on purpose to try to open up the doors and disable the access control, and someone will slip in to the back of house? Or more often, what if the keypad at the front is encrypted? Can you just take off the keypad and just do some wiring and open up the access control gates? That's possible as well. And you can give a risk scores at this point, and what the consequences under this scenario. If someone does have an unauthorized entry to the back of house.
So again, we look at the mitigations. We've touched on this over and over, but as Duncan explained, we're trying to bring this all on a single page. So it serves as a summary for us. So what data are we using, the devices, the public, are they encrypted? Should we really be exposing them? How critical is it for that to be in public view? When we talk about physical barriers, things like HVM mitigations come to mind. How do we want to use them? How do we want to operate them? And then looking at HVM from a physical space point of view, sometimes these items might be sizable, but these days we've got really clever systems. But the clever systems, are they really what they say they are? Do they do what they say on the team? But even if they do that, how do we use our electronic abilities or cyber abilities to support these systems to perform better or perform reliably as we've assumed in our designs? CCTV is a common one. We monitor with CCTV. I think we're really good at protecting that data. But what you would find is, despite the advancement in CCTV technology, for those of you that work with the police or people that work in the crime sector, when you look at CCTV, the guys have got really, really clever at blurring out their faces. So you can see everything, but you just don't see the face. How they do it, I don't know. So what else can we think about beyond relying on CCTV to identify? But when it comes to crime generally, prevention is your best bet. You don't want it to happen. If you can avoid it, then solve it. Because even to get access to the CCTV data is going to be a whole long process. Even when you do, you can't see the individual's face. What do you do from that point on? But it is a mitigation available to us at the minute. So it's just seeing how we get the CCTVs to work in conjunction with the physical barriers that we put in place. So access controls, we can't isolate them, but they are controlled from somewhere. We want to prevent people from taking control of this remotely or maliciously, so to speak. But even when they do, what is the backup we've got? So on the previous project, we've designed access to back of house area was a critical piece of the project. So we designed kind of a double barrier. You go through a secure gate, you come into a holding area, you get checked, and then you go through a second gate. And then the operator of the facility decided that they had to get rid of some of their staff. There were too many. So it was now going to be an unmanned operation. So you go through the first gate, you come into the holding area, the first gate shuts behind you, and then the camera picks someone somewhere away from sight, looks at you. If he's happy with you, he lets you through the second gate. And then somehow the neighboring guys, they somehow figured out that was how the system operated, and then they will still manage to tailgate through this. So you in your remote area, how do you then get to that point in time? So this now highlights the issue of why we need to make sure it's not just physical and cyber trying to work together to mitigate this, but operationally as well. We should make sure that where our systems can't offer the protection they require, they need to have operational procedures in place to support and react quickly to that. And then finally, incident response, which partly touched on. We talked about a short time ago how we evacuate. It's an important part of the piece. So as we do all the good work we all do, we shouldn't forget that someone is got to deal with it when something goes wrong. And inevitably it will go wrong at some point. We try to mitigate, prevent it from happening. But even when it does happen, we still have a responsibility to limit the damage done. And then we have a responsibility to recover as quickly as we can. In the railway, for instance, it's hugely, hugely expensive for trains not to run at any one time. It has a massive impact on the economy. It's not just the trains that don't run at that point. It means so many things just stop. So imagine, say, what's the closest station to us? Charing Cross. If Charing Cross shuts down now, it's not just, the impact is not limited to Charing Cross. It's limited to all the final destinations and destinations in between, and all the economic losses, people in the wrong place and everything. So it's thinking about how we recover as quickly as we can to get things back up and running. So this backup is where we depend more on each other. So from a physical perspective, for instance, if somebody takes control of the CIS and displays an incorrect message that gets trains in the wrong places or gets people in the wrong place and all of that, how do we get people back into this place? Using the access control systems. So we've got the physical barriers, but you now have to deal with, rather than a controlled access, letting in 5-10 people, with the paired flow analysis you've done, you now have to let in thousands in one go, or let out thousands in one go. How do you manage that incident response? It's an important part of the piece, and restoring everything back to normal as quickly as possible. That brings us to the end of our talk. Thank you for listening. Mr. Longwood.
Yeah, thank you. Oh, really?
Thank you very much to both of our speakers for their insightful and thought-provoking presentations. Now we would like to open the floor for questions. This is your chance to engage with our speaker, Duncan and Ter, and delve deeper into the topics we have just covered tonight. Please raise your hand, and a microphone will be brought to you by our lovely volunteers, David and Chris, so that everyone can hear your questions.
Hi, good presentation, thanks. This sounds quite similar to some of the things that industry has been fighting with for maybe the last 15 years or so, maybe a little bit longer. And historically, there's been a lot of pain with this process because of the issues of having to model these attacks and understanding particularly how to control the scope and complexity of what those models end up looking like, particularly when you're crossing system boundaries and you're thinking about combining attacks together. So I'm just really curious, how you're going about modeling this, maybe in an electronic form that you can run simulations against, and how you control the scope of that analysis. And maybe as a little sneaky side addendum to that question, how you deal with the issue of legacy systems. I imagine that's quite an issue in the rail industry. Thank you.
So go on if you want to.
So I'll start from back to front, and halfway through when Duncan will pick up. So the legacy systems are no doubt quite an embedded issue in the railway. Probably not just the railway, I think general infrastructure, but focusing on the railway for a minute, dealing with all of the Victorian infrastructure down to the infrastructure we got from the 60s down to now. We constantly retrofitting and everything. So it's no doubt a challenge, but the conversation has been going on for as long as you say, no doubt. But we need to keep at it. We need to keep at it until something changes, and it is changing, even though it is happening at a snail pace. I'll give you an example with the testing of physical infrastructure devices that get accepted on the railway. Previously, it was around 3 to 4 years, probably longer, to bring a product to market. But now you can do that quicker. You can bring a product to market in about half that time now. From development to acceptance, you could do that in around 2 years now, because we've got more testing centers. We're getting better at understanding how these behave. We're able to do a lot of modeling on software. If you take blast resistance, for instance, the glass we use in railways now, a few years ago, much of that will fly all over the place at the slightest impact. But we've now got glass that we can control how they shatter, even when a blast goes off. And then we've got other tools like tethering and all of that helps hold back flying fragments. Because the danger really, when something goes wrong from a blast perspective, is the fragments. So we've gotten better at protecting that, and the railways are accepting products quicker than it previously did. So notwithstanding the legacy aspects and the challenges of talking to each other, I think the clients have a big role to play in this. Like what Network Rail, for instance, is accepting as a product, is they need to make sure that it's coordinated. So whatever I take the USB-C, for instance, that the EU has forced all of us to use now. Network Rail have got a similar opportunity to do the same. Whatever products they're accepting, one criteria could be that that product is talking to others or has the ability to be modified to talk to others. So in my opinion, I think that is something that could help to address that challenge. You want to add to that?
I touched on most of the points that interesting point. So in the cyber space, there's something called grandfather rights. So it's been in service for a really long time. There's not been much incident, so that's where grandfather rights comes into place. But you touched on when you ask how do we model all the attack scenarios, what the risks are? It's basically a question of where do you draw a system boundary, I think. And also how far you want to go down into that risk. So that's where the primary and secondary risk comes into place. It's all a question on how do you predict the future, really. Is it impossible? I think just prioritize using the resources that you have and use your own judgments and the stakeholders' input of what the reasonable foreseeable attacks are. But the important thing is to keep the conversation going between the two disciplines and not working in isolation.
Cool. Thank you. Next question. Zen.
Yeah, hi. It's working? It works.
Yeah.
Thanks for the presentation. Very interesting. You haven't touched on money. It's always hard to justify the cost of the mitigations. What's your experience? Have we got enough evidence of the threats, and you find justifying the mitigations to actually get the funding to implement them? Are we there yet, or are we still a few attacks short of getting justifications to be implementing mitigations? And the second part of the question is, have you got enough experience now as an industry to actually classify different types of installations to say that, yeah, this is going to be a category A, we go with this set of mitigations? Are we there yet, or is it more bespoke solutions for each particular installation?
Speaking from the East Westfield experience, regarding money is no, because when you look at the safety critical systems, obviously you can't change the design, just change the design of a CO4 systems. But you can protect around it. But even if so let's say installing a firewall or DMZ between your OT systems and the open network, the IPT systems, but even that is very expensive also. So in reality, a lot of the mitigations will come down to physical protection, access controlled, and also data sniffers. They're just never monitoring. So a lot of the mitigation at this stage, they're somewhat just reactive from what I've seen. Obviously, physical security is a lot more mature now. They're not more commonplace. And they're also cheaper to implement, I believe, for some controls. But we've seen similar. We've seen something. This level of convergence in other sectors, in the energy or the healthcare sectors. For example, when you do, say, surgery robots, they don't have a tech classification, but you start to think about how that system is to avoid the system from being hacked, but also think about where the system is stored and how it can access with trained personnel.
If I just add to that, so from funding is always a challenge, but that is where the risk or the quality or depth of your risk analysis comes in. So obviously we can't protect everything, but we identify the critical assets as part of our risk analysis and then try and make the case for that. So the question you would often hear in the room in projects that I've worked on, when we get the clients into the room or the decision makers, it can be challenging to get hold of in big organizations, but when you get them into the room, the question you ask them, if this switch room goes down, trains are not going to run for at least a couple of hours. Are you happy with that? And then it's for them to make that choice. 9 out of 10 times they're going to say, no, I'm not having it. I can't stand 30 minutes of no trains. My phones are going to blow off. So they think about it from that perspective, and then they find funding. They might probably say, okay, we can't do everything you say, but what's the barest minimum we can do? You then offer them that, and I've been opportunity or privileged to be on projects where they've actually gone ahead to do something. And then another scenario that plays out is where you ask yourself the question in the room. I had a client one time, when we were doing blast analysis, trying to put in resilience into busy stations across the network. And the question he asked was, if you were hauled before the coroner, can you confidently say you did all you could to prevent it from happening? So when you ask yourself that question, it kind of brings it home. So when that question lands in the room, everybody goes silent, and then he focuses mind on the importance of doing something despite the fact that there is no money. We then find a pot of money that at least limits the damage. You can't protect everything, but you want to limit it. You don't want a device to go off in a station and half the people in there suffer fatalities. We don't want that to happen. If there's 1 or 2 who are closest to the charge, obviously there's not much we can do to help them, but we don't want that to spread to everybody else. So it's bringing in this level of controls, comes down to risk assessment. So in terms of the maturity of technology, it's not there, but you'll be amazed at how quickly it's grown over the years. Standards have improved. The testing has improved, as I touched on earlier. So it's not as bespoke as it used to be anymore. And then there's a variety of products. Like when you look at HVM products, for instance, if you go across the London network, some of them are planters. The beautiful planters, you don't know that they are even doing any other job. And then some you see your traditional barriers, the bollards, they look flimsy, but a truck can knock them over because the designs have got better and better. So we're making progress, not there yet, but the products available to us now, there's more variety than we had previously.
Thank you. One question here, David. I'll go there next. Thank you.
Hi, Joe. I'm a student currently. Thanks for the presentation. So, and I'm thinking about infrastructure, particularly like physical infrastructure. So I would think that a lot of possible attacks fall under both physical and cyber, especially in that domain. So that means there will be a lot of information shared between these two departments. But in doing that, have you seen that you've opened an attack vector? Because if I was a threat actor, I would then go and I'd be like, okay, I don't have to deal with these really proficient cybersecurity people. I can go and get the information from the other side of that Venn diagram. And I know you said you're going to train people, but the threat landscape changes daily, and the sheer amount that you would need to train them would mean they wouldn't be able to do their job. There's so much to learn. So have you considered that? And if you have, how are you going to plug that hole?
And that's an interesting question you raise, and it's obviously that's exactly how it plays out in everyday projects. Even non-security projects are the same factors play out. But what tends to happen is the specialists do what they do in isolation. We can't break into their systems. What comes to the middle of the Venn diagram is what's common to both. And what's common to both, all it does is it provides efficiencies to both parties rather than double handling. There is one record of it. But the mitigations and resilience and everything else that goes behind it, you can't necessarily break into it in isolation. If we use, say, an access control as the common example we've used tonight, is if you hacked into an SL3 door that is electronically controlled, for instance, you hack into the controls, you might be able to get through that. but it doesn't necessarily mean you can get behind the multi-factor lock. So if I've locked it on secure rooms, I'm not going to rely on the electronic lock alone. So I've got the electronic lock. I've also got the hard lock. So with that hard lock, it's not going to have any link to the cyber. So you've broken into the remote electronic system, fine. That gets you access to that only, but beyond that, you then struggle. So if you look at movies, for instance, where there's break-ins and everything, you find that they come with their power tools and everything, even though they've broken into the system, because there would always be that backup. For critical assets, there's always that extra level of backup, which obviously we can't talk about because it exposes those vulnerabilities.
Yeah, this is a question that we got asked a lot when I was working on infrastructure as well. Because this goes back to the question of how easy it is to disrupt a railway. Why do we need to think about encrypting signaling control system when someone can just throw a brick into the rail and put it on the rail? The answer is yes. If you want to do that, yes, absolutely fine. There's nothing that cybersecurity can do. There's nothing that physical security can do because you can't cover the entire infrastructure with tunnels. But it's also important to think about all the other supporting organizations as well, because the railway system or the operators, they're not working in silos. So if someone is actually planning to do that, or if someone initiates such a large-scale attack, are the security services aware of it? Are the police aware of that? Because they need to equally mobilize an equal amount of resources, and they leave trails along the way if they want to initiate such an attack with this amount of consequences. So this is there are organizations and supporting systems to stop that from happening. Hopefully in the first place.
Thank you. Next questions over there.
Okay, my next. Thank you. Right, great presentation. Thank you very much. I'm going to ask you a question that I know is difficult, but I'm really interested in hearing your answer. Or at least I think it's difficult. I've got the impression from you that you don't think people are taking this seriously enough, or maybe you're having to try to persuade them. Sometimes they need to put the investment in to deal with the risks. So I guess here's my question. Do you think the right people are making the decision about how much is enough security? And who is that? Is it the operator? Is it the manufacturer? Is it the regulator? Thanks.
Yeah, it's a really good question, and interesting as well. I think the right people are there. The question in my mind is whether they've got sufficient levels of authority, because the reason I say that is one of the challenges we face on the railway. I'm sure most people that work in the railway would agree, is decision making by the clients. So you send something to them to sign off, and it just makes the rounds in the houses. They go from one person to the next. No one is willing to put their hand up. And we can criticize them all we like for passing the buck, but when you dig deeper, sometimes they don't have the authority to make the call. So I think the authorities might be the missing link, because some of them are very knowledgeable in what they're doing. I've worked with a security controller for a client in the past. He had, the dreams he had, the way he wanted to work. For a supplier like myself, obviously, he was providing a lot of funding to me, so I was really pleased with that. But he simply didn't have the budget. He was giving us contracts that I didn't have a budget for, but because it was what he agreed with what we were proposing, he wanted to see it done, but he didn't have the budget to pay for it. And then he kept agreeing to change upon change upon change. And we got to a point where we needed paying, and the bill was like, he was taken off the job because he was making decisions he didn't have authority for. So I think the missing link could be the authority for this individual. But in terms of knowledge, I think generally the knowledge is there, the competence is there, they get regular training and all of that. And then sorry, I think I missed the other part of your question.
Well, the microphone's gone, so
don't worry.
Thank you. Well, the first part was, do we have the right people making the risk decisions? And the second one was about who you'd say it should be.
Yeah. So the first part is, I think it's partly what we're trying to drive. Is the whole point that motivated us to talk about this really, is making sure that conversation, no one is outside the room when those conversations happen. So I gave an example earlier about how we thought we had spoken to everyone, but we left out the station manager, and he had a critical piece of info that led to a vulnerability in the system, which would have been avoided if we'd spoken to him earlier. And so there's really, in my mind, I don't think there's one person more important than the other. That's why I'm keen for people to have reasonable, I mean, we all can have the same level of knowledge, but I think there is a basic awareness that we all need to have. So I've been on projects where, as a requirement to come onto the project, you had to do a basic level of security training. It's all online, e-learning, a bit of testing, and then you go through some vetting as well before you get on it. A lot of projects are adopting that, especially when you start to go into the defense, nuclear, and all of that. You see those sort of arrangements, but it still comes up short because it's e-learning. So how do you verify that people are actually doing it right? How do you test their competence? How do you ensure that you have the right individuals? I mean, even there's a case that's been going on this week, for those of us that get news, breaking news and all of that, about a soldier who was selling info to enemy state. So you never can really protect everything, but you just want to be able to limit it, and more importantly, you want to be able to respond. So like this example I've just given of what's been going on in the press, you can see that somehow they had an effective response, that the damage was limited, if at all there was any. Yeah.
Anything to add, Duncan? I think we have time for one last question, if there's any.
I just wondered if you guys live in the real world, because if you travel, say, on Thameslink, things are constantly breaking down. Overhead lines fall down, points get jammed, there are suicides. The Thameslink comes to a halt at the slightest thing going wrong. So wouldn't it be better if instead of all this academic stuff, you actually fix the broken points and the overhead lines that are falling down?
Yes. Yeah. So again, it all comes to operation and maintenance. Yes, I mean, assuming that's always going to be maintained. You got 99.9% uptime in the various systems. But what if there's a security attack? Again, this is not something that's happening daily, probably. So it's not everyone is throwing, not every day people are trying to break into a control room or try to hack into signaling systems, which is the focus of what we're talking about today. So what you just mentioned, it comes to reliability and the condition of the asset. Yes, that would be nice to get that up and running first and give the better passenger experience. So the benefits of just fixing a loose post would be more impactful than say design putting a firewall in place. But if there's an attack, there's something that we would like everyone to consider in the design process and operational process.
Good answer.
Yeah. So just to add to that, everything you say is correct. I mean, the essence of everything we talk about is just to minimize downtime on the railway. So you will be interested to know that, you'll be shocked, as you say, to find the amount of downtime that we suffer on the railway that is due to vandalism, which is directly linked to the security we're talking about. So sometimes people just go get access to track, open up a cabinet, really dangerous cabinets. The railway is a very dangerous environment, but somehow they manage to go on there and then take a fuse box out of it. And that's breach of security, and it brings the entire line to a stop. So it's all linked. So if you don't secure the railway, you're still going to suffer downtime, irrespective of how well you maintain the lines and the electrical systems and everything else. So it's all interlinked, no isolation. But everything you say is 100% correct. That's the whole aim of all of this, is to make sure that the railways operate as a system without or minimizing the breakage.
Cool. Thank you. Thank you both, and thank you everyone for such an engaging and thought-provoking Q&A session. This evening, we explore the challenges and the opportunities of integrating physical and cyber security within the railway systems. It's clear that a holistic approach is essential for enhancing system integrity in this rapid evolving sector. I hope this session has sparked new ideas and provided valuable perspective for everyone here, whether you are working directly in the field or have a broader interest in the system security and engineering. Once again, let's express our thanks to our speaker, Ter and Duncan, for sharing their expertise and giving us such deep dive into the integration of physical and cyber security in railway systems. Thank you also to all of you for your participations, questions, and engagement this evening. And before we conclude, I'm delighted to tell you about our next IET Central London Network lecture, which is our special Christmas lecture. So mark your calendars for the 11th of December, when we will explore a topic on space economy, tomorrow's world today. Our speaker will delve into a fascinating and rapidly evolving space economy, uncovering how innovations in this frontier are shaping our lives today and what the future might hold. This promises to be a captivating and inspirational evening, perfect to close out the year. It will be held right here in the IET Savoy Place, and as always, it's open to all. So feel free to invite your colleagues, friends, and anyone with a passion for science, technology, and innovation. Don't miss out the opportunity to join us. Lastly, I'd like to remind you to take advantage of the networking reception following this lecture, which is an excellent opportunity to connect with peers and engage in further discussions, and feel free to ask the both of them more questions there. Thank you. Cool. Thank you.